Go ahead.
Good afternoon. My name is Josh Lang, and for my study, I study the effects of ibuprofen on the aggressive behaviors of male beta splendens. So in the past, in the recent past, there has been an increase in the level of consumption of pharmaceutical products by humans, and that in turn has led to the increased levels of pharmaceutical chemicals in the environment, according to Arnold. So products such as anti-inflammatories, painkillers, contraceptives are all found in groundwater, drinking water, surface water, and sewage water. The beta splendens species have been tested in the past with regards to exposure to metformin, which is a chemical mainly used or often used in medicine for type 2 diabetes. And this study conducted by McLaurin showed that there was a decrease in the aggressive behaviors of the beta splendens species after exposure to metformin. Also, the Australian damselfish was also tested with regards to water acidification, or the increase in carbon dioxide levels in the water, and this study showed that the turning preferences of the fish were effective. And turning preferences being just as humans are tend to be either right-handed or left-handed, fish have a tendency to either usually turn right or usually turn left, and that's what turning preference is. So based on this, we know that chemical changes in the environments of fish can affect their behaviors. So, but a gap that I found when I conducted my research was that there is no study that examines the effects of ibuprofen on the beta splendens species, shown right there. So beta splendens was chosen for the experiment because they have they show very distinctive, very easy to track aggressive behaviors when provoked, and also ibuprofen because ibuprofen is found usually in nature at about 8 nanograms per liter, according to Poiger. So from that information, I developed my research question of what are the effects of exposure to ibuprofen on the aggressive behaviors of male beta splendens. And from this question, I derived my hypothesis that ibuprofen would have a dampening or diminishing effect on the aggressive behaviors of the fish. The reason that this hypothesis was created is because since ibuprofen is a non-steroidal anti-inflammatory drug that is often used as a painkiller, it would seem more possible than not that it would have a dampening or diminishing effect on aggressive behavior. So to conduct the study, 15 male beta splendens were each placed in individual containers of 1 liter of water. Once all of these fish were placed into their enclosures, they were allowed to acclimate to their new environment for about 2 weeks. After those 2 weeks, a 5-day period of data gathering was started, and each day aggressive behaviors were observed and recorded for the fish without any exposure to ibuprofen. So this was sort of the control group. After those 5 days, on the 5th day, after data was gathered, there was a 100 microgram per liter solution of ibuprofen that was created, and there were 15 enclosures created with this solution. Each enclosure had 1 liter of the solution in it. So after these were created, the fish were then placed into these new enclosures and allowed to sit for two days again to kind of acclimate to their new environment. After those 2 days, the same 5-day period of data gathering and observing was conducted with the same methodology. So in order to quantify the aggressive behaviors of beta splendens, the aggressive behaviors were classified into 2 distinctive behaviors, one being gill flaring and one being tail beating. And this methodology was used in the McLaurin study that I referenced earlier. So gill flaring is identified as the repeated and sustained spreading of the gills, and tail beating was identified as sudden rapid change in direction or a burst of speed of the fish. So just to demonstrate a little bit what a gill flare looks like, As you can see right here, where the gills would be on the fish, it's just kind of smooth, flat, curved. You can see that on the silhouette, but in this picture, the gill is flared. You can see that it does kind of protrude out and changes the shape of the silhouette. So this was very easy to observe and to record. Tail beats, unfortunately, it would be difficult to demonstrate it using pictures, but again, it was the rapid change in direction or burst of speed from the fish. Very distinctive, very easy to track. So in order to provoke aggressive behavior, since the fish isn't just aggressive for no reason, according to McLaurin, male beta-splendens show aggression in the presence of another male beta-splendid. So in order to simulate the presence of another fish, a mirror was placed into each enclosure in order to provoke aggressive behavior, and this methodology was used in a study by Magliozzi. And then tracking and recording the behaviors. So once the mirror was placed into the enclosures, then a 15-second video was recorded of each fish one by one, and after the video was recorded, it was watched back once for observing and recording of the number of occurrences of gill flares, and then once more for the number of occurrences of tail beats. And if there was anything that might have been missed, the video was just watched another time. This methodology was also used in the Magliozzi study. So from the results, this chart shows the number of occurrences for the treatment days, which is the second 5 days after ibuprofen was introduced, and the non-treatment days, which was the first 5 days before any chemicals were introduced. So this is for gill flares, and that is for tail beats. The red dots represent the occurrences of tail beats or gill flares for the non-treatment days, and the blue represent the treatment days. So the reason that you can only see a few blue dots, especially in this chart right here, is just because there was a lot of overlap in the data. So there were some like blue dots here and here and here, but they were just covered by the red dots. So it would just be useful to pay attention to the trend lines shown. For gill flares, the trend line of the non-treatment days is much greater than the trend line of the treatment days, suggesting that ibuprofen did have a dampening effect on the gill flare behaviors. And same thing with the treatment days, or same thing with the tail beats. The non-treatment days were significantly greater than the treatment days, again suggesting that ibuprofen had a damping effect on aggressive behavior. These two histograms show the average occurrences of gill flares and tail beats, and the blue for the non-treatment days and the red for the treatment days. So as you can see in both charts, the occurrences of gill flares and tail beats for the treatment days were much greater than that, or much greater than the non-treatment days for that of the treatment days, again suggesting that ibuprofen had a significant dampening effect on aggressive behavior. So in order to kind of confirm these assumptions that were made based on the data, a t-test was conducted, and the results of the t-test showed that for both gill flares and tail beats, the t-stat value was greater than the t-crit value, and the p-value was less than 0.05 for both gill flares and tail beats. And based on the results of the analysis, the t-test did confirm that there was a significant statistical difference in the occurrences of gill flares and tail beats from before exposure to ibuprofen to after exposure to ibuprofen. Therefore, ibuprofen did have a significant effect on the aggressive behaviors of beta-splendens. So from that analysis, the conclusion was made that ibuprofen had a dampening effect, or the hypothesis was proven correct that ibuprofen would have a dampening effect on the occurrence of gill flares and tail beats, the aggressive behaviors of beta-splendens. So the implications of this conclusion is that it just sheds light onto the fact that the disposal of chemicals into the environment by humans does have an effect on the environment, specifically when it's disposed into bodies of water, it has an effect on the marine life. So this just calls for a certain increase in awareness that people should have when disposing of what they dispose of in their everyday lives. And it also suggests that there should potentially be more efforts to clean bodies of waters of chemicals. It also calls for more research on other fish and other types of chemicals in regards to the effects that the chemicals have. The limitations of my experiment were that the study was both planned and conducted only over a 3-month period of time, and data recording itself was actually only conducted over a 12-day period of time. The first 5 days, the 2 days of letting the fish sit, and then the second 5 days. Also, only 15 fish were examined in this experiment, and also a 100 microgram per liter solution of ibuprofen was used, whereas in nature, ibuprofen only occurs at about a level of 8 nanograms per liter, so much less than what was observed in this experiment. Also, the video, when taking data, was only 15 seconds long, and so basically from these limitations, it cannot be, it can't just be assumed that ibuprofen has as big of an effect on beta splendens as it did in this study. However, to address these limitations, if the study were to be repeated again, a larger period of time should be allowed for data gathering for both treatment and non-treatment data. More fish should be examined. Lower concentration of ibuprofen should be used as to better mimic that of what occurs in nature. And also, the fish should be recorded for a longer time in order to take more accurate data. So, in the future, from this experiment, it would make sense that ibuprofen should be tested on other types of fish, other types of chemicals should be tested on other types of chemicals should be tested on the beta splendens species, and all in all, other chemicals should be tested with other fish. Also, research should increase in ways to reduce the amount of pharmaceutical chemicals that are disposed in the environment, and all these sort of directions go towards the goal of reducing the footprint that humans leave on the environment.
Thanks for job, Josh.
What was one obstacle or challenge you encountered while implementing your research method, and how did you address it?
So one thing that I planned on doing was having all the fish connected to a filtration system. So the filtration system had several shelves and tubes going kind of everywhere. They would have gone into each tank, and all of the water in the entire system would be connected. So all of the water in each tank would have been connected. At the bottom of the system, there was a large kind of bucket or basin with a large volume of water in it. So when I was in the 2-week period of letting the fish kind of sit, I would notice that every day the water level in the basin would decrease a little bit, so water was being evaporated. And so I realized that if I treated the whole system with a certain concentration of ibuprofen, if the water level would decrease, I'd have to put more water in it, because if I didn't, the system would then turn off. So if the level of that water was decreasing every day and I was putting more clean water in it, the concentration of the ibuprofen in the whole system would decrease, and I didn't want that. So after doing a bit of research, I just kind of learned that the beta splendens are a very hardy species of fish, so they can live in an environment without filtration for a good period of time. So that's
Right. Considering the different approaches and perspectives that you could have explored, what was the most difficult to incorporate into your research?
the most difficult perspective to incorporate, I would say, would be the kind of the environmental aspect of what levels of ibuprofen are actually found in the environment. Basically just for the reason that it was very hard to find any research that told me at what concentration ibuprofen is found in the environment. So until I had any sort of evidence as to that, it would seem kind of pointless to, there would be no real purpose to the research if it doesn't really occur in nature. But once I did find that research, I was able to continue the study.
Thank you, Josh. If you had 3 more months to work on this research project, what additional research strategies would you put into practice?
Well, kind of like I said before, I would probably, well, I would repeat it, and I would make the period of time allotted for data gathering much longer. So 5 days, and with doing that, I would decrease the concentration of the ibuprofen, just because the lifespan of a fish is obviously more than 12 days. But since I only had those 12 days to conduct the research, that's why I had such a high, that much of a higher concentration of ibuprofen as was found in nature. So if I wanted to mimic what is in nature, I would make the data gathering occur over a much longer period of time, and then I would lower the concentration of ibuprofen to better mimic what happens in nature, and then from that, observe whether that concentration had any significant effect.